Okay, hello everyone. I welcomes to all in our lecture series on superconductivity. In this lecture series, we are going to discuss introduction part of the superconductivity, Meissner's effect, and mathematical explanation of Meissner's effect or validation of negative magnetic susceptibility. Then we are going to discuss London's equation and London penetration depth. Then we are going to discuss variation of London penetration depth with distance and temperature with some important questions also we are going to discuss. Critical magnetic field with important questions, 𝒂𝒐𝒏 effect and critical current, BCS theory on superconductivity, variation of critical temperature with isotope and some important questions. Finally, we are going to discuss type 1 and type 2 superconductors and their applications. This lecture series is very much essential for BSc, BTech, MSc, MTech and also various entrance examinations like CUET, CPT, JAM, GATE, NET, TIFR, etc. Okay, so let us start to discuss one by one topic. Our first topic is your introduction to superconductivity. Okay, so let us start. This is the introduction part of superconductivity. Superconductivity is the phenomenon by complete disappearance of electrical resistance in various solids when they are cooled below a characteristic temperature. This temperature is called critical temperature, or it is written as T subscript C. Just follow this figure. If we are going to consider normal conductor and we are going to decrease the temperature, then its resistance will be decreased. But at 0 Kelvin, it's not 0. It has some value. But if we have a superconductor and we are going to decrease the temperature of of a superconductor, then at a particular temperature it will be give a transition of its resistance. That means at a particular temperature the resistance suddenly drops to 0. This temperature is called as the critical temperature. Okay, this is itself a definition. One more question may you can found in your exam. You just remember, or you have to write by your own word. This phenomena or superconductivity was first discovered in 1911 by Kamerlingh Onan. He is the Dutch physicist, and he awarded Nobel Prize in 1913. What was his experiment? In his experimental study, he found that the electrical resistivity of mercury disappears suddenly when it is cooled below temperature 4 Kelvin or minus 269 degrees centigrade. Hence, Tc of the mercury will be 4 Kelvin. That means if we are going to consider a mercury, then at 4 Kelvin, its resistivity suddenly drops to 0 or resistance suddenly drops to 0, or you can say disappears completely. That was his experimental study. Okay, then after several uh, co- uh, superconductors has been discovered. Some of the example here you can see: aluminum, niobium, copper oxide, yttrium, barium oxide, magnesium diboride, etc. And normal conductor, if we are going to consider, gold is a very good conductor, but it is not a superconductor. Steel, brass, copper, these are the normal conductors. That means if we are going to decrease the temperature, suppose we are going to consider the gold, its resistance is not to be 0 at 0 Kelvin. But if we are going to consider aluminum or niobium at a particular temperature, it suddenly resistance suddenly drops to 0. Okay, these are other examples that you may have to remember, but I suggest that you have to remember this one. This is called the so-called YBCO, yttrium barium copper oxide, and its TC transition temperature around 92 Kelvin. And other threes, these three may I suggest that also you have to remember: bismuth, strontium, calcium, copper oxide, transition temperature 110 Kelvin, and here 𝑺𝒐𝒏𝒂𝒐𝒂 8 transition temperature 134 Kelvin. So these materials, oxide materials, presently these oxide materials are the hot topic in now in the research field of your superconductivity. Okay, so I suggest at least these two you have to remember: YbCO and bismuth, strontium, calcium, copper oxide. Okay, okay. Some of the important results here. Here you can see these properties not changed in superconducting transition. This is the superconducting transition. Suppose we have a superconductor and we are going to decrease the temperature, and this is the resistance. At a particular temperature, it suddenly drops to zero. This temperature is called as your critical temperature or transition temperature. Okay. So this state, this is 0 Kelvin. This state is your superconducting state, and above Tc is your normal state. Okay, I forgot to say you that here all the superconductors above Tc behaves as normal conductor. Here you can see that normal conductor and superconductor graph after Tc both are same for superconductor and normal conductor, but before Tc or at transition temperature, if we are going to consider for the superconductor for a particular temperature, the conductivity drops to 0, but for the normal conductor it will decrease but not to be 0. Even if at 0 Kelvin it is not to 0. Okay, so for a superconductor above Tc it behave as normal conductor, below Tc it behaves as superconductor. Okay, okay. So these are the properties which are not changed in superconducting transition. That means below Tc or at Tc, these properties are not to be changed, but these properties are to be changed in superconducting transition. So I suggest that here I written 5 points which are changed, not changed, and here also 5 points which are changed, properties which are changed. I suggest that at least 3 to 4 you have to remember. This question asked oftenly in your exam, 3 to 4 mark, 3 to 4 mark. Okay, okay. So here the properties which are changed, here you can see the change in intensity of of diffracted X-ray was not noticeable, which indicates that during superconducting transition means at Tc, the electronic or crystal structure remain almost same. Because we know that suppose this is the XRD data, uh, these are the peaks and this is the 2 theta and this is the intensity. So there is no change of intensity and the peak position itself. So here you can see, here you can say that uh, at the transition from normal normal conductor to superconducting state, normal conducting state to superconducting state, there is no change of its crystal structure or electronic structure. Okay, there is second point, there is no appreciable change in reflectivity either in visible or infrared region, or you can say there is no appreciable change of optical properties. Photoelectric properties also not changed. Elastic and thermal expansion properties also not changed. In the absence of magnetic field, there is no change of latent heat of latent heat at superconducting transition. So these are the properties which are not changed at transition from normal to superconducting state of a superconductor. The properties which are changed here, the electric properties of the material totally changed. That means after this temperature, after this Tc, it behaves as normal conductor. Below this Tc, it is a superconductor. That means its resistance is 0. So totally changed. Electric properties totally changed. Above critical temperature, so this is Tc. I will correct it. Okay, this is Tc. Here I have to correct first. Okay, here I corrected. Off I written, and here this is the Tc. Okay, critical temperature. Resistance is more above critical temperature, what I discussed. Okay, this is your TC, transition temperature, and below TC resistance is 0. The magnetic properties of the material undergo a change in the same way as electric properties that we are going to discuss in our next class or lecture. How it has changed in the pure superconducting state. Practically metal or superconductor behave as a strong diamagnetic nature or diamagnetic susceptibility, and shows Meissner's effect. About Meissner's effect and corresponding diamagnetic susceptibility that we are going to discuss in our next class. But superconductivity is destroyed above a particular magnetic field called the critical magnetic field, which is represented by Sc. These things we are going to discuss next class. You just remember this one. Magnetic properties is to be changed. That's it. Okay. The specific heat also to be changed, or uh, you have to write discontinuously it will changed at transition temperature. Thermoelectric effect like Seebeck, Peltier, Thomson disappears in superconducting state or superconductivity state. The entropy decreases in superconductivity state. Okay, so these are the 5 points or 5 properties which are changed in superconducting transition. Okay, so this is all about the introduction of superconductivity of a superconductor below below TC. Below TC, what I discussed, that below TC it will be a superconductor, but above TC it acts as normal conductor. Okay, next class we are going to discuss Meissner's effect and negative magnetic susceptibility. Okay, thank you so much for watching this video. Thank you.